Hi, welcome to another session on circles. We have been taking on questions questions on applications of the theorems. Herein I write the next one, which says prove that the circle drawn on any one of its equal sides of an isosceles triangle as diameter bisects the base. We draw a circle to this question first. Look at the circle. It will be like this. The isosceles triangle, why I am drawing this first, because once I draw the isosceles triangle it might have been difficult for me. I'll just draw the isosceles triangle here. I hope it now looks one like. This is the diameter, which is named A, B, and this might be the C. We have to show, we will drop this A. We have to show that this is getting bisected, so I'm dropping A, B, D to DC. What is given in this? It says A, B. Given part I write is AB is equal to AC of the isosceles triangle ABC. Now taking AB, which is the diameter, taking AB as the diameter, it is one of the sides of the equilateral triangle, as it says. We have drawn a circle which intersects the circle at the which intersects the side BC at the point D. We have now joined AD to prove it is BD equals DC. How do we do it? Now what about the angle ADB, this angle? If you look at, this is the angle drawn on the semicircle. We have previously discussed angle drawn on the semicircle is a right angle. So angle ADB is 90 degrees. On the other hand, angle ADB plus angle ADC is equal to 180 degrees. They make a linear pair. If I substitute this ADB with 90 degree, our angle ADC also we will be getting as 90 degrees. Now look at the triangle ABD and ACD. We try to prove the congruency of these two triangles. Once we prove the congruency by CPCT, we'll say that BD is equal to DC. Now in triangle ABD and triangle ACD, angle ADB equals angle ADC to be 90 degrees. AB is given equal to AC and AD is common. So triangle ABD is congruent to triangle ACD by RHS congruency. Thereby CPCT can give us our proof. So by writing CPCT, BD is equal to DC, that's what we were to prove. Let's move on with another question. I draw the figure first. Says there is a diameter. I draw, I draw the diameter which is named as AB. This is A, which is B. I just write the part of that question as well. It says AB is a diameter of the circle. It also says CD is a chord equal to the radius of the circle. So we have to draw CD, which is equal to the radius, which is like OB. Suppose I name this as OB. I draw that chord here. This is named as C and this adds D. The next step, it says AC and BD when extended, they intersect at a point E. So now let us extend AC and BD. This is AC extended, and let's see where, when BD gets extended, where do they meet here? This is the point which says is E. Now what is the part of the next to it? It says prove that angle AEB will be equal to 60 degrees. We have to prove this angle to be 60 degrees. Now let's get into our proof. To do so, we'll be joining this OC. We also need to join OD. We also might need to join BC. Now look at the triangle OCD. So I write the proof here. In triangle OCD, I just highlight it by drawing it. OCD. It was informed to us that CD was equal to the radius, so they all three, OC, OD, and CD, they are all equal because they are all the not they are all radii, but they are all equal to the radius. They are all equal to the radius. That makes triangle OCD an equilateral triangle. Let me keep it short as TRI, triangle. So each angle, that means angle COD as well, 60 degrees. This one is 60 degrees then. What is angle CBD? Sorry, CBD. This one. What will be that angle? That will also be 60 degree. Now why? I write it first. Angle CBD will not be here 60 degrees. It will be half of COD. So that will be half of 60. That makes it 30. Angle formed at the center is double the angle formed on any part of the remaining circle. So if this angle is 60, CBD will be half of that. It becomes 30. So I write now this adds 30, this being 60. Angle ACB, on the other hand, this one ACB is 90 because that's an angle in the semicircle. It's an angle in semicircle. Fine. Angle BCE will then be this one, will be 180 minus angle ACB, because they both make linear pair. So it is 180 minus 90, so it is 90 degrees. Now this part is 90 degrees. Look at the triangle BCE as a whole. This one, maybe I highlight it using another color. This BCE. In triangle BCE, angle BCE is 90 degree. We had also calculated angle CBE to be 30 degrees. Because if CBD is 30, that makes CBE as well 30. So what is the rest of the part? That is BEC will be 180 minus BCE and CBE. So that's 180 minus 90, minus 30. That's 120. So 180 minus 120 gives us 60 degrees. So this part is 60 degrees. That's what we were supposed to prove. We got our proof then. Let's move on with another question. I just write the question here first. It says if O is the circumcenter of a triangle ABC and OD is perpendicular to BC, what do we have to prove? We say we have to prove angle BOD equals angle A. Let's draw the figure for it. I want to draw O. This is a circumcenter. Now I need to draw the triangle ABC. I hope this O, which is the center, is imaginary drawn and it looks like the circumcenter. This I'll mark as O, and my triangle is ABC. OD is perpendicular from O to BD. Yes. I think I'll need to join this radius for my proof as well. So I already joined them. I named this as D as given in the question. We have to prove BOD means this angle equal to this angle. Now to do so, we know that OB is equal to OC. They are the radius of the circumcircle. So it will make also angle ODB equal to angle ODC. They are perpendicular, thereby making these two both 90 degrees. We also know that OD is common, thereby proving the congruency of triangle OBD and triangle OCD. Now if we have proved the congruency, thereby we can prove also that CPCT by angle BOD is equal to angle COD. These two are now equal. Angle BOC can be then written as twice of angle BOD, or we can write it is twice of angle COD as well. Now this arc BC, this one, subtends this BOC triangle at the center and angle BAC on the remaining part of the circle, thereby making angle BOC twice of angle BAC, or completely a big angle A. So BO, we can substitute this BOC as twice of angle BOD. We could have actually substituted it with either this or that, but as per our proof we need BOD, so I kept it as BOD is equal to twice of angle A. BAC is equivalent to angle A. So if I cancel these two, I'm getting angle BOD equal to angle A. So we also have proved this one. Thank you.